Alright, I'm going to cheat on this video because I realized after I published one that I left the symmetry. I didn't make a video about symmetry, and to be honest, I'm pretty burned out this afternoon. So I found my notes. Tuesday, Thursday, these are from your class. And we're going to talk about checking for symmetry. On a relation or on a function. Now there's three types of symmetry that we're gonna talk about. Okay, we want to know if the relation has x-axis symmetry, whether it has y-axis symmetry, or whether it has symmetry, with respect to the origin. Now, x-axis and y-axis symmetry are much easier to visualize than origin symmetry is. And that's because when we're talking about the top two types of symmetry, we're talking about folding our paper and seeing if things match up. Okay, so for example, if I fold my paper on the x-axis, top to bottom, there on that parabola that's laid over on its side, the top matches to the bottom, and so that graph would have x-axis symmetry. A function like, let's sneak a teeny one up here, that parabola would not. If I folded my paper top and bottom on the x-axis, the top would not match the bottom. Let's look at the same two functions, but I'm going to draw this guy up here and this one down here. Similarly, if I want to talk about y-axis symmetry, that means if I fold my paper on the y-axis, does the left side match the right side? Okay. The graphs below my words there each have that type of symmetry, but notice if I fold my paper on the y-axis, that parabola that opens to the right, okay, the left and the right sides don't match up. So this would be no, this would be yes, okay, this would be yes, this would be no. Origin symmetry, again, is harder to describe, so I'll just jump straight to the punchline and not talk about the paper thing, because without me actually standing at the board flipping a paper around, like my Tuesday, Thursday students saw, it's a little more difficult to do here on the whiteboard when you're just seeing the whiteboard. A function has origin symmetry if for every point xy on the graph, the point negative x negative y is also on the graph. If we want to think about similar explanations up here, okay, the x-coordinate is the same on both of these points. Whatever the y-coordinate is on the top one, it flip-flops and is negative y on the bottom one. In reverse, down here, the y-coordinate is the same on both of those dots, but the x-coordinate is the one that flips sign. So maybe I'm at 2 at -2, then I'm at -2, -2. Okay, maybe I'm at 1, 1, and I'm at 1, -1. Okay, depending on, I went right to left there instead of left to right. So algebraically, when we're trying to determine whether a graph has a certain type of symmetry, okay, it looks like I started at the board with y-axis symmetry in class, and I probably had the other stuff on the whiteboard. Okay. If a graph is going to have y-axis symmetry, or if we're checking to see whether it does, every place there's an x in the function, in the equation, in the relation, we're going to replace it with negative x. Okay, we'll replace all the x's with negative x, and then we're going to do the work, meaning I'm going to raise it to the powers or distribute the two or whatever I need to do. And then I'm going to compare to what I started with. And I say, does it match? Does it match what I started with? Okay. So if I'm looking at the function y equals x squared here on the left, I'm going to replace x with negative x. If I square negative x, I still get x squared. Y equals x squared matches the y equals x squared that I started with. So yes, that graph would have y-axis symmetry. in the middle, if I replace x with negative x, the absolute value of negative x is the same as the absolute value of positive x, which means I get the same function back out of that. So yes, it has y-axis symmetry. On the third one, however, if I replace x with negative x, when I cube negative x, I get a negative x cubed. That is not the same as the function that I started with, so I say no. That function does not have y-axis symmetry. If I'm checking for y-axis symmetry, I'm going to replace the x's with negative x. It's the opposite letter. That will also be true if I'm checking for x-axis symmetry. Wrong slide. Wait, here's some more y-axis examples. Let me do this for a moment. There we go. You can pause the video if you need to write those down. I'm not going to talk through the steps on that one. If I'm checking for x-axis symmetry, take it away, I'll put it back. If I'm checking for x-axis symmetry, then we're going to do the opposite. We're going to replace y with negative y. Every time that it happens, if there's a y squared, it becomes, I'm squaring the negative y. If there's a plus 3y, I have plus 3 times negative y. But every y turns into negative y. Then we're going to do the work. Okay. And then we're going to compare. Compare it to the original. If it's exactly the same as the function or relation that I started with, then yes, it has that type of symmetry. Now, when I say function, for something to have x-axis symmetry, it cannot be a function. Look at our example that we sketched at the beginning. If the top lines up to the bottom, that does not pass the vertical line test. Okay. But some of the relations that we work with, some of our circles, those sorts of things, okay, will have x-axis symmetry. So here are some examples. Again, pause the video if you need to write them down and study them. Look at what I did there. Some of them do and some of them do not. Most of them do not have x-axis symmetry. If we're going to check for origin symmetry, for a function to be symmetric about the origin, we're going to do both. Okay, we're going to replace both x with negative x and y with negative y. And then we're going to do the arithmetic. And then we're going to compare it to what we started with. On the next page will be some examples. Again, pause them, write them down, look at them, see if you understand what happened. I have one of each. They're not terribly exciting. And if you have questions about this, let me know. Because that may or may not be all I said about that. I'm going to click through these slides again, and you can, I checked for all three on this graph. You can pause it and write it down. And then we went on to end behavior. So I guess that's the only one where I checked for all of them. Okay, please be in contact with me. Monday, Wednesday, Friday, people, you haven't seen this before. Tuesday, Thursdays, if this is still blurry and fuzzy to you, please let me know.